we're going to be talking about the motors and more stuff relating to the electronics part of it. So right now I'll talk about all of the motors that we have. So there's 4 different types of DC motors. So we have 2 rev ones. This is the rev HD hex motor and the core hex motor. So the core hex motor axis of rotation is perpendicular to its body, while the HD hex motor, its axle of rotation is parallel to its body. So the next type of motor we have is our Go Builder motor. So this is commonly used by our team because it has a variety of RPM settings. So what RPM is rotations per minute. So if you have more rotations per minute, you have less torque. But if you have less rotations per minute, you have more torque. And so lastly, we have the Tetrix motor. And Tetrix is not commonly used by our team because it does not have an encoder motor, an encoder wire. So to talk about the cabling of our motors, so most of them have a power cable like you see on this one, which is a black and red wire that connects to your control hub. So, and then also many motors, like the Rev and Go Builder motors, have an encoder wire which looks like this. And basically what an encoder is, it measures how many rotations the shaft on your motor has done. And overall, this just increases our navigational accuracy and makes it easier for us to code. So next we have our Rev servo motors. So mostly servo motors, they have a limited angle of rotation because they are much smaller, but they also have more precision and control over what angle they are moving at. So this so the Rev servo motor it can be programmed to like spin continuously and not stop, but it can also be programmed to have a very limited range of movement, and you can do all of this through the Rev servo programmer.
Another important part of the Rev Hub control system is the sensors. So there are a lot of important elements that have to do with sensors. Firstly, the ports that they go into. So there are 3 different types of sensors. There's the analog sensor, the digital sensor, and the I2C sensor. So all these have a variety of sensors, but the main two that we're going to use, the distance/color sensor, the touch sensor, the IMU, and the camera are going to be mostly digital. So let's first get into it. Let's start again. Another important part of your FTC robot is sensor input. So the first thing to know when doing sensors is what port it goes into. So there are 3 different sensor ports on the Rev Hub. Firstly, the analog, the digital, and the IC12. And all sensors have a different port that they want to go into, and we'll cover each of those in a little bit. So firstly, the most simple type of sensor is the touch sensor. So this simply gives a binary yes or no statement if the touch sensor is pressed or not. This gives true, this gives false. The next sensor that's a little more important is the color sensor. The color sensor is able to tell the RGB values of any color that we base it on. Additionally, it's also a distance sensor, and it can detect a range of up to 2 meters. It'll give the distance of the closest distance object in centimeters or in inches. Both of these sensors are digital cables, meaning they go into these ports right here. So these are the cables that you use to connect your sensors. Another very, very important sensor is the control hub, but not as exactly the control hub. There's a sensor within the control hub that's very important, and that's called the IMU. The IMU serves as a dual device that has a gyroscope, which means it's able to tell the angle that the robot is facing in all 3 axes of rotation, meaning this way, or this way. We're able to tell, and this is able to improve the navigational accuracy. Additionally, there's also an accelerometer inside of the control hub, meaning that it's able to detect how fast you're moving and how fast you're accelerating. Finally, the last firmware sensor input that's also the most advanced is the camera. We are able to take screenshots and images with the camera to detect the locations of important objects on the playing field using neural pathways. So we are able to train neural network models using TensorFlow, a Google device, to detect objects using trained picture samples. This may sound complicated, but it's actually very simple using the TensorFlow Google object tool.
So to make all these work, you have to have the proper path through all of your control hub and driver station. So the control hub is basically like the brain of your robot. So it controls everything from your motors to sensors to everything. It tells everything what to do. And that is connect through Wi-Fi through the driver station. And the driver station stays with your team during a game. And it had a drop down menu which allows you to pick which code you're going to play, and that is connected to the control hub. Additionally, you have the game controller for you to control your robot with this. So this is connected with the wire to your driver station, and so this is connected to your driver station, and the driver station is connected to your control hub. So that tells your motors what to do based off of your controller.
The driver station is also a very important device for the control hub system. The driver station is kept by the team during an FTC match, and it is used to control all functions of the robot. The robot, as you can see, will be controlled by this interface right here, where you can run programs by choosing out of the two drop-down menus. Additionally, you can also configure settings with the robot, including configuring it, meaning you can define where the sensors are going to be and what ports they're going to be located in. You can also do many other things, such as adjust the Wi-Fi settings, the name of the robot, adjust the controls type, the control scheme, and all those sort of things. But the main function is to communicate from the team through the driver station to the control hub. Another way that the driver station helps is through the driver control period, where the controllers are plugged into the USB ports at the bottom of the driver station. The driver station will take the input from those gamepads and relay it to the control hub.